Hi everybody, and welcome for joining us. My name is Sandrino Di Mattia, and I'm a Microsoft Azure consultant in Belgium. I work for a large consulting company, Real Dolman. And so our team specializes in building Azure applications and helping out customers adopt the Microsoft Azure platform. And besides that, I'm also an author on justazure.com, which is a great website where you can get started with Azure. It has a few interesting series on cloud services, diagnostic storage, and so forth. And I also run the blog fabriccontroller.net. So if you're interested in new Azure features or technology deep dives, be sure to take a look at my blog. Now, in this session, we'll be talking about Azure Files, which has been announced at TechEd North America 2014. And actually, Azure Files is a shared drive as a service. So we'll look at the details in a few slides. But it's important to know that having a shared drive managed by Microsoft that you can use from different cloud services, web and worker role instances, and from different virtual machines opens up a ton of new scenarios that we'll be looking at in the next few slides. So the agenda for this session is a closer look at how Azure Storage works and how Azure Files fits in. How we can get started with Azure Files using different technologies. We'll be comparing Azure Files to the traditional blob storage and to the disks we'll find back in virtual machines. So, and then we'll end with a few scenarios. I'll demo a few of them, and we'll also wrap up with a few interesting links you can use to look at some other Azure File examples. Okay, so Azure Storage. Well, actually, Azure Storage has been around for a very long time now. And internally, in its core, it's actually exposing three different abstractions. So the first abstraction is blob storage, or Azure Blobs. And this is actually the most popular of the abstractions, and it allows you to take a file, upload it to a high available, durable, persistent store, and this file can optionally be exposed through a public URL. So if you're building applications that require to save media files, videos, log files, whatever, and you also want to optionally expose it to your users, then blob storage is the way to go. So besides blob storage, we also have storage queues. And so storage queues allow you to trigger your background processes. So instead of having your users, when they click a button, send out a mail immediately, you can simply send out a message to a queue saying, okay, this user should receive an email, or we want to generate a file for that user. And so the large process that will be running can run in the background. So your background process will empty the queue, will look at the tasks that need to be executed, and can go on from there. And the last abstraction we used to have is table storage. So table storage is a NoSQL database and allows you to store your data in, well, actually it's a key value store. So your data is stored in actually, you have a partition key, a row key. Those two values are indexed, and all the other values are stored beside those two values and are not indexed, so you cannot really search on those values. So these are the three abstractions we had up until May 2014. And so during TechEd, Microsoft announced a new abstraction, being Azure Files. Now, before we look at that, I also wanted to talk about two additional features we have in blob storage. So important to know, blobs can be stored both as block blobs or as page blobs. Now, a block blob is built or optimized for sequential reads and writes. So this means that the typical scenario for a block blob is downloading a file, which you'll be downloading in a sequential way. Now, page blobs are optimized for random reads and writes, which means they're best suited for NTFS workloads, for example. Now, and this is also why drives and disks are actually available as page blobs in your storage account. So Azure Drives is a feature that has been available in cloud services for a very long time. And so drives allow you that when your web and worker roles start, that you actually mount a drive letter to a blob in your storage account. And the same goes for disks. So disks is what we'll have what we have in our virtual machines. And so a disk does exactly the same. So you can mount a drive letter in your VM, and finally that disk will be stored as a page blob in your storage account. And so finally we also have our new abstraction, Azure Files, and it's this abstraction we'll be focusing on today. Now, if we look at how Azure Storage works internally, Azure Storage is built up with a distributed replication layer, and on top of that we have a massive scale-out and auto load balancing index layer. Now, for our three classic abstractions, all of those have been or are exposed through a REST API. And the new abstraction, Azure Files, is actually a little bit different. So it's also exposed through a REST API, but besides that, it also exposes an SMB 2.1 endpoint. And this means that you can mount a file share as a share. It's actually a share that you can mount as a mapped drive. So let's see how you can use Azure Files. So let's say you create a new storage account in the West Europe region. Well, in that case, the Azure Files endpoint will also be active for that storage account. And you can actually connect to it from a cloud service, from a virtual machine, and from Azure website. Now, cloud services and virtual machine today allow you to interact with Azure Files using the REST API, just like you would do with blobs, for example. But on top of that, you can also use the SMB 2.1 endpoint. So this means that if your web and worker role instances start, you can mount a mapped drive which points to an Azure file share. And the same goes for your virtual machine. So in your virtual machine, you can use the net use command to create a mapped drive also pointing to Azure Files. Now, an Azure website and the web jobs do not allow you to mount a mapped drive. So the only way to interact with Azure Files would be through the REST API. Now, if we look at other regions, so let's say my Azure Files deployment is in West Europe, and I want to connect to a file share from another region. Today, this is only possible using the REST API. So it's not possible to have a VM in North Europe, for example, and mount an Azure file share that's in West Europe. That's not possible. And the same applies for your resources that are on-premises. So even if you have a site-to-site VPN, today it's not possible to mount an Azure Files share in one of your on-premises resources. Now, you'll typically start by creating a share in Azure Files, and you can do this using PowerShell, for example. So in this slide, you can see that using PowerShell, I create a new Azure Storage context. And after that, I simply create a new share in that context. And so once you have your share, you can start using it. So an example could be that you use the AZ copy tool or the Azure copy tool, which is available in the Azure SDK. And you could use this tool to copy full directories from your on-premises servers to an Azure file share. We can also use the SMB endpoint. And so what you see here is the netuse command to create a mapped drive, and also the CMD key command to persist credentials. And these are the two commands you'll typically use on a virtual machine if you want to mount a share as a mapped drive. Okay. Now, typically when you're deploying a cloud service, which would be a web and a worker role, you'll be using some code that will be running in the webrole.cs or the worker-role.cs, the onStart method. You could write some vanilla pinvoke code to mount a shared drive, or you could use the library, which is also available on NuGet. This library is called radog.storage, and this gives you an extension method on the cloud file share object, which easily allows you to map a drive letter to an Azure file share. And it's important to know that depending on a context, the mapped drive will or will not be available. So this means that the credentials of your storage account, pointing to an Azure Files endpoint, those credentials are always persisted per user. Now, if you create a mapped drive, so let's say I have a Z drive pointing to my pictures share, so it's important to know that this mapped drive is persisted per user context. So, and each user can have one or two different contexts. So this means that if you're an administrator, your user can have a normal context, which would be not elevated. And besides that, your user can also have an elevated context, which should be the administrator permissions. So it's important to know that if you mount a mapped drive under the elevated context, that specific drive will not automatically be available in a normal context. So if you want the mapped drive to be available in both of your contexts, you will need to map it twice. Now, what we'll typically see is that our web application uses, its application pool uses a service account to authenticate, a dedicated application pool identity. So if you want to persist credentials or create a map drive for that specific user, you will use run as in command line to store the credentials, again, of your Azure file endpoint and create a map drive for that specific user. So if we look at the REST endpoint, you can also, you can do normal REST calls, so HTTP calls, or you could use the storage client library, and you'll see that the API is very similar to the API you'll see in blobs, in tables and queues. So in this example, I'm simply creating a file client. I'm getting a reference to a share, to my reports share. And if it exists, I simply download a file report.txt, which resides in the root directory. So let's continue by comparing Azure Files to the existing Azure Blob storage. So if we look at the durability options, currently Azure Files only supports locally redundant storage and geo-redundant storage. So, for example, we don't have access yet to read-access geo-redundant storage. If we look at the accessibility and connectivity, both features give you a worldwide access to the REST API. But for the SMB endpoint, it's important to know that it's only available within the same region. So this means the endpoint is available cross subscriptions, but not outside of that specific region. And so the endpoints, okay, so we have our HTTP endpoint, and for the share itself, you'll use a traditional / notation to connect to your share. Now, Azure Blobs does not support directories. It has a flat namespace in which you can simulate directories, but there's no real directories available in Azure Blobs, while they do exist in Azure Files. And if we look at the case sensitivity of the files, you'll see that Azure Blobs is case sensitive to be compliant with HTTP. And Azure Files is actually case insensitive but case preserving. The capacity for Azure Blobs, it's actually the capacity of your storage account. So today storage accounts are limited to a maximum of 500 terabytes, which means you can have containers of up to 500 terabytes. Now, if we look at Azure Files, an Azure file share is only limited to 5 terabytes. The throughput is also a bit different. So for blobs, you get 60 megabytes per second throughput per blob. So this actually means per file, while in Azure Files, you only get 60 megabytes per second for the complete share. So even if you have 1,000 files in that share, the complete throughput of your share is 60 megabytes per second. And for the object size, Azure, a blob has a 200 gigabyte limit, a page blob 1 terabyte, and in Azure Files, your files are limited to files of up to 1 terabyte. The build capacity in Azure Blobs, you're built for the bytes that have been written to a blob, and in Azure Files, you'll be built for the actual file size. Azure Blobs support shared access signatures. Now, this allows you to publicly expose your files in a secure way. So you're able to restrict access to your blob. So you can say, okay, I'm creating a shared access signature for a specific permission. So a user could potentially only read a file or only upload a file. And this can be limited in time. So we can have a time limit of a few minutes, a few hours, to make sure that no one else can access the blobs. If we look at Azure Files today, there's no support for shared access signature. So sharing a direct link to an Azure Files is today, in a secure way, is not possible today. And then the client libraries support multiple languages, and this goes for both blobs and Azure Files. Now, if we compare Azure Files to Azure Disks, and Azure Disks are the disk we'll be mounting in a virtual machine, you'll see that an Azure Disk is always exclusive to a single virtual machine. So only one specific instance at a time can mount a specific Azure Disk. While with Azure Files, and this is where it gets interesting, in Azure Files, your share can be accessed from multiple virtual machines and multiple web and worker role instances, all at the same time. Azure Disks support snapshots and copy, while Azure Files do not support this yet. If we look at configuration, our data disk is connected at startup of the virtual machine. So this is handled by the Fabric controller, and this is something we typically set up in the portal or through PowerShell. While Azure Files, it is something you would do once the OS has booted. So it will be up to you to, by using PowerShell, the command line, or anything else, to connect to a share and create a mapped drive. So the authentication is built in, and for Azure Files, you'll do it using netuse, CMD key, and you'll use the credentials of your storage account to connect to the Azure Files endpoint. Azure Data Disks and Azure Disks in general support caching to improve the performance of your reads and writes, while Azure Files do not support this today. And if we look at the REST access, files within a VHD cannot be accessed using a REST API. And even if it was possible, a VHD is always mounted in a virtual machine, which means that the virtual machine also has a lease on that VHD, which is a page blob in the end. So if we look at Azure Files, files that are stored in a share are obviously exposed to the SMB endpoint, but at the same time, they are also accessible through the REST API. The max size of an Azure disk is 1 terabyte, and for Azure Files, you get a maximum file share of 5 terabytes, in which you can have 1 terabyte files. If we look at the IOPS, you'll see that the IOPS of one disk is 500 IOPS, and for Azure Files, you get 1,000 IOPS for the complete share. The throughput stays the same for the disk and the share. The only thing to note is that the throughput of 60 megabytes per second is per disk, while for Azure Files, again, this applies to the complete share. Now, one important point is the I/O traffic. So when you're writing and reading from an Azure disk, this goes through the virtual disk driver, while for Azure Files, this actually uses network bandwidth. So this means that it uses the same network interface as your application would be using to communicate with your users. So that's something you'll need to take into account. And this will, based on the used bandwidth, you will potentially need to choose a different VM size, because the bandwidth, the available bandwidth of VMs depends on the size of your VM. Now, if we look at limitations, you can have a maximum of 16 disks, data disks attached to your VM, and this also depends on the size of your VM. So, for example, for a small instance, you're limited to 2 data disks. For a VM, this is 4, and so forth. While for Azure Files, you're actually limited to the available drive letters on your VM. So this actually means that if you need more storage without wanting to upgrading the size of your VM, Azure Files could be a better scenario for you. Okay, and so next we'll be looking at a few scenarios, and we'll be going through a few demos of these scenarios. So a few typical scenarios would be lift and shift. You have an application running on premises. You want to migrate it to Azure with little to no effort. Well, in that case, virtual machines and Azure Files could be the best solution to set up a high available application. A CMS, for example. CMSs typically use media folders where you have images, videos, and other types of files that you want to expose to your users. If we look at a traditional CMS like Umbraco, it has support for Azure Blobs, but a traditional setup will always use a local disk or DFS. And now today with Azure Files, it becomes much easier to do migrations like these to virtual machines. You can use Azure Files as a central logging system. You could use it for remote backup. So we often work with customers that have MySQL databases. Well, now with Azure Files, they could mount an Azure file share in their Ubuntu VM and create remote backups for their databases by pointing those backups to a mounted Azure file share. Now, one important point to know about Linux support is that you'll only be able to use Azure file shares with the last two Ubuntu distributions available in the portal. Besides backups, you can use Azure Files Share for a software repository where you store ISO files and other tools you'll typically use in multiple virtual machines. You can use Azure Files as a centralized configuration store, for example, with IIS shared configuration, allowing you to set up your websites, your FTP servers once, store that information in an Azure file share, and have your other virtual machines point to that configuration. Another interesting scenario is Lucene. An issue we often have today when building web and worker roles is that when we want to use Lucene, we will typically synchronize the Lucene index with our storage account and then with the other instances. Now, Azure Files again enables you to have a worker role instance updating the Lucene index, and then on the other side having web role instances reading from that index and querying it. So another scenario is in Service Bus, where you could use the file share data bus and point it to an Azure file share. On-premises replication, where you could set up a continuous replication between your on-premises virtual machines or a DFS and use the REST API to sync your files to Azure. And also a high available FTP server that could be useful for running important processes using BizTalk, for example. So we'll cover a few of these scenarios in the next demos. And we'll start out by a lift and shift scenario. So imagine we have an application running on premises. And this application is an ASP.NET web application, and it could point, this application could persist its files on a local disk or on a DFS. And what we'll do is simply take that application, migrate it to Azure Files, and have it point to, migrate it to an Azure virtual machine, and have it point to Azure Files. And this will allow us to deploy this application in a high available setup where the application is deployed over multiple virtual machines pointing to the same Azure file share. So before you can start using Azure Files, you'll need to sign up for the preview feature because today Azure Files is currently in preview. And once you've done that and you create a new storage account, you're able to create a new Azure file share in that storage account. So I already had a storage account. So what I'll do is take the credentials of my storage account and use PowerShell to create a new Azure share. So I'll be first creating a new Azure storage context, which points to my storage account. So that's why I need the credentials of my storage account. And the next thing I'll do is simply create a new Azure storage share, which could be DB backups, and which uses the context we just created. And so now our file share is available, and we can mount it in our virtual machine. So I have a virtual machine here ready. I'll start up the command line. Okay. And I'll start by using the netuse command to create a drive, which could be the M drive, which will point to the Azure File Service Demo storage account. And I'll also have to give the name of the share, which in this case is the DB backups share. So I'll need my storage account credentials again. And so if you look at this command, it simply says, okay, create an M drive, have it point to the DB backups share in my storage account, and here are the credentials for my storage account. And that's it. So if we take a look with File Explorer, you'll see that my DB backups share has been mounted as the M drive. So now I have up to 5 terabytes of space in which I can persist my files. Okay, so let's take a look at the application we'll be migrating to an Azure virtual machine. So at the moment, this application is running locally. And as you can see from the web config, it's actually pointing to a directory on my D drive. So this is something we'll change because we want to be able to deploy this application over multiple instances. So instead of creating a stateful VM that will keep the images locally, we'll make a few changes to make sure that the images are persisted in a file share, which means that the images will be available from multiple virtual machines. So on my VM, I'll simply start by creating a new website. Enterprise Pix. I'll set up the physical path. It will be running on port 80, so that's it. Okay, so we have an empty website. This virtual machine has been set up to support web deployments. So what I can do now is simply publish my web application to the VM. And what will happen now is Visual Studio will deploy all the content of my application to the virtual machine. So if we go and take a look at the website, we'll see our application here. And I can now simply go to corpwebapp.cloudapp.net. And you can immediately see the exception popping up. So, of course, the web config still pointed to the file or the directory on my local machine. So we'll need to adapt that. And as you can see here, I already have a share mounted, pointing to the pictures share. And it will be on this share that I'll want to store the images of my web application. So what we could try is to say, okay, instead of pointing to this local directory, simply point to my Z drive. Now, the issue we'll see here is that my web application does not know the Z drive. And this is because of the context. If you look at my application, I'm actually outputting the current user of the application. And here the current user of the application is Enterprise Pix. And this is because my website uses or runs in an application pool. And this application pool has its dedicated user. So the Z drive was mounted under my user account, but the website runs under a different user account. So in that case, the context will not be the same. So the Z drive will not even exist from the point of view of my web application. Now, what I could do is, again, using the netuse command and a cmd key command, set up the mapped drive and the credentials for my web application. Or you could also manage this from a code perspective. So what I did is simply create an HTTP module. And this HTTP module uses some code from the Red Dog storage library, and it simply allows you to mount a drive. So in this case, again, the Z drive, have it point to an Azure file share, and pass the credentials of your storage account. So what this will do is mount a mapped drive pointing to a file share within the context of your web application. So as you can see, I'm not touching the original application. I've simply created an HTTP module that I'll be using in my web application. So, and in order to use it, I'll simply adapt the web config and make sure the web application, so if you look at the web config, the only thing I need to do is insert a line which will add the HTTP module to my web application. And so what will happen is that when my web application starts, the init method of my HTTP module will be triggered and it will mount the mapped drive. So this allows me each time the application starts to map the share to a drive letter. So I've added the module in the web config, and what this will do is create a map drive Z, the Z drive, and so what I'll finally need is to point the picture spot to the Z drive. Okay, so if we try this again, you'll see that my web application is running correctly. So the files are loading. And let's say if I delete the cities folder on my VM, which would be in pictures. If I delete it, you'll see that the images in my web application are also deleted. If I upload a picture, a Microsoft wallpaper, I didn't adapt any of the code of my application, but you'll still see that the Visual Studio wallpaper is added in the Azure file share, and so this would allow me to create a high available application running over multiple virtual machines pointing to the same file share. Okay, so our lift and shift scenario was pretty easy to do. And what we'll do next, so maybe we have a new requirement from our customer saying, okay, I have my application running locally, but I want all the files on the local disk or on the local DFS to be continuously replicated to my Azure file share. Now, what we did then is create a simple console application. So in a real scenario, you would typically create a Windows service. And this console application uses the file system watch class internally to monitor a specific directory. And each time a file is added to that directory, a file is deleted, changed, renamed, whatever, we will intercept that change and also apply that same change to our file share. And in order to do that, we'll simply use the storage client library and the REST API to interact with our file share. Because remember, an Azure file share, it connect's SMB endpoint is currently limited to the region in which the storage account resides. So me, from my machine, I'm not able to use the SMB endpoint. So our console application, we simply set it up to monitor a specific directory and then have it point to a storage account and a share, which in our case would be the pictures share. So I'll start the synchronization tool. Okay. And what I'll do next is go to my desktop where I have a few cloud images, and I'll take these cloud images and copy them to my local directory. So this is the synchronization tool. Let's maybe take the Microsoft directory. I'll copy the Microsoft directory to my local directory, and you immediately see that the synchronization tool kicks in. So it starts by copying every file to the file share. And if I go back to my virtual machine and take a look in pictures, you will see that all the Microsoft images have been uploaded to the share. And using the REST API and some simple .NET code, I'm really able to set up a continuous replication between on-premises resources and the Azure file share. Now, if you would implement this in production, besides a file system watcher, you would also have other processes running continuously that would also detect, deletes, renames, edit files on the side of the file share and set up a two-way synchronization. Okay, so if I refresh my application, I'll see that even if it's running in Azure and I added the files locally, they have been replicated to my Azure file share. Now, and the last demo we'll be looking at is building a scalable FTP server. So if I go back to my virtual machine, we might have a new requirement from our customer saying, okay, I want to be able to manage the images on the virtual machine using an FTP server. So what I prepared on the VM is a script to set up an FTP server. And one of the other scenarios we have is a central ISO tool software repository. So what I did is set up another share, the ISO share, which I'll also be mounting. So I'll do a net use of the iDrive. I'll take my credentials. And I'll also map an additional drive letter on my VM pointing to the ISO share. It's net use. So here you have a new file share popping up, which contains a few, some software that my developers might need on their virtual machines. And it also contains a few scripts. And these scripts allow me to simply set up an FTP server on my VM. And so what this script does is it simply adds a new FTP in IIS. It points the root directory of that FTP will point to a directory on my VM. It will open up port 21 on the firewall, set up the ports for the passive FTP, and also use the public IP of my FTP server, of my cloud service, to make everything work correctly. So what I did before this is set up the required endpoints in the Azure portal. I'll just quickly change this here. And so I'll simply go to the mapped drive I just added, go to the FTP folder, and I'll install or call the script to install the FTP server on my virtual machine. And if we go to IIS, my FTP server is running. Now, the issue with this FTP server is that it points to a directory which is on my VM. So this isn't something I want. I want this to actually point to an Azure file share. So what I could do is simply say Azure file service demo.core.windows and have it point to my pictures share. Now, if I spin up a tool or a client like FileZilla and I try to connect to the application, so this would be my corp webapp.cloudapp.net. Now, if I connect to it, you'll see that we get an exception that the user cannot log in because the home directory is not inaccessible. So let's take a look here, test the settings. You can see that there's an issue connecting to the file share. Now, the way FTP works is a little different, and it uses pass-through authentication. So this means that it will take the credentials of my web user and try to authenticate with that web user on the Azure file share. But this isn't something we want. We actually wanted to use the credentials of our storage account. So in order to do that, we'll set up the FTP with a specific user, and we will be using the name of our storage account and its key as the credentials for the FTP's root directory. Now, you'll see that I'm not able to use these credentials because a user does not exist on the VM itself. And the trick is to create a new user, which would be, again, the name of our storage account. As a password for that user, we'll be using our key. And we'll add it to the users of the VM. Yes. Okay. So now I have a user on my local VM with the credentials of our storage account. I set up the same user on my FTP server for the physical part of the FTP server. And if I then try to reconnect, made a small typo in the name of the share. So now if I reconnect, I get access to the images that are uploaded through the application, that are replicated using the local tool, and I can do the same management here. So if we open up the application in the browser, you'll see all the Microsoft images. Well, I can simply take the folder, delete everything, refresh the application, and you'll see that the files are no longer there. So we've seen how easy it is to lift and shift an application to Azure virtual machines and Azure files as a backend to create high available applications. We've seen how easy it is to set up synchronization between on-premises resources and an Azure file share using the REST API. And now you can enable new scenarios like a scalable FTP server without having to worry about the storage aspect. So without having to set up a DFS, for example. Let's get back to the presentation. So what we did is in a lift and shift scenario, we set up the ASP.NET application in our VM and have it point to the Azure file share using the storage account credentials. In our on-premises replication, we just created a small application with a sync engine using a file system watcher, monitoring a local folder and have it persist all its changes to an Azure file share, which then allowed us to deploy our web application in a virtual machine and finalize the migration. And so for the high available FTP server, I now did it on a single instance, but now that we have a stateless FTP server where the files are not persisted on the VM but in Azure file share, it's easy to start adding new instances. And so what you typically do is have your VMs ready, set up a load balanced endpoint, in my case port 21, where you will have load balancing over all our instances. Set up the required ports for the passive FTP, and then have all the FTP servers point to the same Azure file share. And so that's how easy it is to set up a high available FTP server. Now, I'll end this session with a few interesting links that can really help you out to discover the new Azure file service. There are a few interesting posts on the Azure Storage blog that will introduce you to the Azure file service and also give you a little bit more information about how you can persist connections. So with the CMD key commands, for example, and it also goes into a very deep detail on how the contexts actually work. And the context issue is the main issue you'll be having if you start using Azure files. So again, it's important to know that depending on the permissions of your user and the context in which you're running, that a mapped drive might not be available, and that you'll need to take additional actions to make it available in the context of your application. There's also an interesting link on MSDN containing all the details I just talked about, comparing Azure files to blobs and drives. Azure Files also works on Linux, so there's a great video on Channel 9 explaining how you can do just that and enabling remote backups and other scenarios on your Ubuntu virtual machines. I also have a blog post that goes into very deep detail on how you can start using Azure Files in your web and worker roles. And now an interesting tool is the Cloud Portam application. And this is actually an online browser for your Azure storage account. And it also supports Azure file shares. So if you're not, you don't feel like creating and managing your shares using PowerShell, well, in that case, you can use this tool to do it all through the browser. Now, when I set up the scalable FTP server, I used a script which is available on the last link, and this script will easily allow you to set up a passive FTP server on one or more instances, allowing you to create a high available FTP server. And that's it for me. So thank you again for joining Azure Conf, and I hope you enjoy the rest of the sessions. Thanks.